can use it with a right angle triangle if you want to, but we use sine law when we don't have a right angle triangle. So sine law is going to be our tool now. So in grade 10, we deal with right angle triangles, and now we're moving on to a bigger world of non-right angle triangles. So in 2.1 and 2.2, we dealt with things on a coordinate plane. 2.3 and 2.4, we're going to just go back to regular standalone triangles. Okay. Okay, so you use sine law when you have two angles on one side and you're trying to find that other side, or you have two sides in one angle and you're trying to find that angle. Okay, so this is sine law. Sine law is a ratio. And what do we know about the numerator of this? If they're lowercase letters. It's a side, right? So if it's a lowercase letter, it's a side. Okay, so you're never going to use 3 at a time. You're only ever going to use 2. And the letters don't have to be A, B, C. They can be X, Y, Z. They can be alpha, beta, epsilon, if you want. They don't have to be these. What you do need to know is that it's side A over angle A. Side A over angle A. Side B over angle B. So if this was an X, this would be X over sine X, right? And you know, you guys know, you know this. I'm just going to draw you a triangle anyway. And if this is angle A, we know it's an angle because it's a capital A and it's on a vertex. We know that side A is the one across from it, right? So we remember that from our review. You knew that in grade 10. But this is why it's super important that everybody's labeling the triangle the exact same way, because now it really matters in your formulas. Okay? So angle A will always be calculated, denoted with a capital letter. Side A should be lowercase. And I've seen the sine law be done in reverse, where sine A is on top and side A is on. Okay, maybe a little bit of B. Side B is on top and side B is on bottom. That's fine, just as long as all of these get flipped. Does that make sense, everybody? So you can do it either way. This is the way I was taught. This is the way I'm kind of stuck to, but it doesn't matter to me if you flip it. You just can't flip this one and leave this one. That would make me very sad and it would be bad math. Okay, so from Kelly's house to her friend's cabin is 1.8 kilometers. So here's Kelly's house, here's the friend's house, and that is 1.8 kilometers. Just for the record, it's very hard to draw triangles and put information on them when you're trying to do it digitally. He wants to know the distance from her house to the store on the edge of town. What I'm trying to find is this right here. Okay, that's what I'm trying to find. Now, there's also something else that you know about the triangles. All the interior angles are equal to 180. So really, I have this piece, I have this side, so I need this angle. And you guys are like, I like that angle. Right, so in order to find theta, that's going to be 180 minus 88 minus 66. What does that give me? 26? Sure. Can I trust you, Pat? It is a Monday morning. So this is 26 degrees. So we know that the red pair is 26 degrees and 1.8. So that is what I call my known pair. It has all the information in it. So I always like to list that one first. So I'm going to have side 1.8 over sine of 26 degrees. Okay. So now I'm going to switch colors just so we keep this. So I'm trying to find this side. And so I know that its maximum angle is going to be the one across from it. So it's going to be side x over sine of 88. So the only reason why I needed that 66 was to help me find that angle that I wanted. Okay? So sometimes, and this is what I like to call a known truth. It's true in any triangle. You don't have to prove it to me. You don't have to show me the math. Like, you can just put down that this is 26. Like, you can do that's math done on a calculator, like that sort of thing. Okay, so now I have a fraction on one side, I have a fraction on the other side. Resist the urge to put this into a decimal right away. Rearrange your entire equation. So we're going to cross multiply. You guys with me so far? So I'm going to cross multiply. So I'm going to have 1.8 times sine of 88 equals x times sine of 26. I want x by itself. Divide by sine 26. So those will end up canceling each other out. But if I divide this side by sine of 26, I have to divide this side by sine of 26. So notice I've lost my degree symbol somewhere along the way. Not the end of the world, because I'm not in my final answer yet. Am I looking for an angle, or am I looking for a distance? Okay, so I know that my units are not going to be in degrees, right? Hopefully they're going to be in kilometers. Okay, so let's talk math for a second, ladies and gentlemen. Up here, your numerator, it's like it's in a giant bracket. That has to happen first. So 1.8 times sine of 88. You cannot do that. No, because this is an actual number, this is a decimal number, and this is a decimal number. Okay. So then when I do this multiply, when I've done that multiplying, and then I'm going to divide by sine of 26. I'm going to leave all those decimals in my calculator, because in you should not be rounding until your final answer. Does that make sense to everybody? So if you round it to 4 digits for the sine of 88, divide by 4 digits of sine of 26, you may or may not get the exact correct answer, and that will be a half-mark deduction of rounding. Harsh world. Oh, you guys are rushing. So this is going to be 4.10360. We'll stop there. And then we're going to round to 2 decimal places. So 4.10 kilometers. When I say 2 decimal places, even if it is a 0, you must state it. Does that make sense, everybody? No. No. You can jump right to this. But if I said 2 decimal places, you need to have that 0. Okay? That would be a half-mark rounding problem if you went 4.1. Because I specifically said 2. Oh, so harsh. So harsh. No, it doesn't. Okay. That's beautiful, right? We didn't have to solve the triangle. We're only one side away from it. Like, we could totally do it, but not. So this, like, Sine Law is so easy. Like, it doesn't get any harder. Well, I said that I lied, because tomorrow's lesson is going to be harder. Don't miss ambiguous cases tomorrow. Okay? Don't miss that. So if you're, or tomorrow you have your quiz. Sorry, don't miss Wednesday ambiguous cases. Okay? So yeah, skip tomorrow. It's just a quiz. No big deal. Okay. So like I said, drawing digital triangles and putting stuff on them is very difficult. So instead, I just write them out. And it saves me a lot of trouble. Makes you guys draw the triangle. Okay, so all this means is my triangle is going to have vertices, so corners labeled PQR. Angle P is 36 degrees. Side P is 24.8, and side Q is 23.4. Now there's something I know. We'll talk about it in a second. And my diagram should never go to scale, and sometimes this will be the 150-degree angle, and this will be like 12 degrees or something like that. It's just unfortunately, there's some things. So I'm going to put P down here, and so that's 36, and side P is 24.8, and then I'm going to put Q down here, so side Q is 23.4, so that means that's R. Totally. Your triangle just may not come out around the scale. And as long as you are perfectly okay with that, I know some people are not okay with that. And they'll redraw the triangle. There is no adjacent, there's no opposite, there's no hypotenuse, because we are no longer in a right angle triangle. So now it's fair game. Only on right angle triangles. And this is, we have no, there might be a right angle in it, but we can't assume, especially if I'm drawing it, even though it might look like a right angle, you can't be guaranteed, especially if I'm drawing it. Okay, so do you want to know why I labeled my triangle this way? I'll let you in on my little secret. Okay, so this was 24.8. You guys agree with me? And its angle measurement was 36, so I know it's an acute angle. This side, 23.4, slightly smaller than 24.8. So I know that angle Q is also going to be, it's going to be a smaller angle than 36. So that's why I dropped it down here into the acute one. So if we have a really long side, and you do this with your hands, if you have a really long side, that means you're going to have a really big angle. If you have a short side, you're going to have a small angle. Big side, big angle. Small side, short angle. Short angle, small angle. If you have a short side, you have a small angle. So I'm going to tell you what took me years to visualize that. I'm not a good visualizer. So I knew that Q had to be down here in the other acute corner of my triangle. So that's why I labeled it that way. There is nothing wrong if you went P, Q, R, and you're going to find out that R is an obtuse angle. I know this because 36, I know Q has to be less than 36. So let's say 36 plus 36 is 72. That's going to be an obtuse angle for sure. So these are things that over time I've been able to rationalize and reason in my head. If you calculate this and this is your R and it's 102 and your diagram is whack, I'm going to be fine with that. I'm not marking you on the diagram. Your diagram is going to help you calculate. Okay? If I ask you, which I will never do, to draw a triangle to scale, then we have a problem. Then you need a protractor and you need a ruler and things like that. I will never ask you to do that. So just know that I labeled it this way because I was reasoning ahead of it. I don't expect you to be doing that. Okay. So the whole goal of this is to find angle R. You guys would agree? But if I look at this, I can't jump right to finding angle R because I don't know side R. I don't know what side R is. So I can't have a ratio with two unknowns in it. But what I can do, I can find Q, and you guys know that all of these should add up to how much? 180. So you're going to do that extra step. So we're actually not going to solve what it's asking me for. And you're walking into my class. Oh. All right. So that means I'm going to set this up. So what I like to do is I like to set up my knowns first. So the ratio that has all the information in it. And I don't know why I like to do that, but I like to do that. So I have 24.8 over sine of 36. Okay, I always like, it's this habit that I got into, and you guys do not have to follow that. It's just something that I do. And then we have 23.4 and sine I'm not going to use theta, I'm going to use the letter because it's going to help keep me organized. And I will change that Q into a theta, I'm sure, at some point, and then you're going to deduct me a half mark for introducing the variable. Okay? All right, so we're going to cross multiply. Okay, we are solving for an angle this time. So if we're solving for an angle, my units will be in degrees, and I know I'm going to have to use the second function button on my calculator. So we are going to, we're solving for an angle. Okay, so you guys, grade 10, you should remember that, right? Like anytime we're solving for an angle, we're going to use that second function button. So I got 23.4 times by sine of 36. Ooh. How do you guys feel about me jumping right to that? Okay, so what's going to happen here is this is going to be, has to be less than 1, because we know the sine value is not going to be greater than 1. So handy dandy calculator. And again, I'm going to let my calculator do all this work for me. Okay, now here's the deal. People are like, do I have to write down all of these? I'm okay with you writing down 4, but you have to use all of the decimal places on your calculator. So you should get 0.554603828. Right, so I want to isolate that sine Q. So I'm going to divide this side by 24.8, and I'm going to divide this side by 24.8. Those will cancel each other out, and I'll be left with that. Okay. All right, so in my calculator, and you don't have to write this stuff down, I write it down in my notes so that when I go back and look, I'm writing it down in your notes. When I go back and look at it, I remember what I did. So I'm going to do sine -1. Not -1 means that I've used my second function button in my calculator. I have to write down all of those. And you guys know what something to the -1 is, right? Right, it's the reciprocal of sine, right? So it's like we divided sine out. But we use this notation because it's what's in our calculator, but mathematically we're dividing sine out. It's very cool when it all like clicks and makes sense. And this would be 33.68343169, and that's in degrees. So, should we round to the nearest whole degree? I think I said to do that. Didn't I say to do that? 100, because it was a side, and this one says measure angle R to the nearest degree. Okay, so have I found angle R yet? Yeah. No, that's angle Q. You're saying you did. What is show on? Okay. It'll work out the same way. I'm going to use 2 decimal places here. So to find angle R, and you guys know that that's the symbol for angle. And if I'm not drawing it and it's typed out, it's a little bit different. It's not a greater than sign. See how the angle is horizontal, that bottom line is horizontal, and the greater than symbol is like a triangle, it's angle. But if I'm drawing it, they all look the same. So this would be 180 minus, what's my other angle? 36 minus 33.38. it asks me to round angle R. Oh, right? It's going to work out the same way though. This would be 110 degrees. So again, it's really important that you pay attention to what the question's asking you to do, because that's important. Okay. That's it. That's all. We're done.